Hello all, welcome back to this series of CPLEX OPL tutorial. In this tutorial I want to show you how you can write the optimal decision variable values into the Excel file. In our previous tutorials we already implemented this model, and today I'm going to show you how you can write this how you can write the values of the optimal values for this model into the Excel file. If you remember, in this example we had only one type of decision variable. I'm not saying one decision variable, I'm saying one type of decision variable, which is xi, because the number of decision variable depends on the values of these index I. So the definition here was this xi was the number of product I produced, and we had a total of, for example, 10 products initially in the problem. Later on we modified it, we implemented the problem so that we had 5 products. Okay, so depending on the instance, the example, you may have different products, and depending on the number of products, the number of decision variables change. So here, if the number of products is 10, then you have 10 decision variables, or if the number of products is 5, then you will have 5 decision variables. So this is important to know how many decision variables you have, because while writing the solution to Excel file, it will be important. And let me show you this implementation. If you remember, we had several run configurations, and the run configuration in which we read the data from the Excel file was this, and this was the example, and this is the Excel file that we are reading the data. Number of products is 5, available time, available material, and all the other data are written here. Okay, so let me run this model and show you how we read the variable values, the x values. As you can see, the solution is here, and when we click on this x over here, you can see the solution here, as you can see in the solutions tab. But also, if you click on this button over here, then the values of the x variables will appear here. And if you like, you can just click the top row, and by pushing down the shift button and the down button at the same time, you can select all of them, and by clicking Ctrl C, copy it, and then go to an Excel sheet, for example, and by clicking on Control button plus this V, Control V, you can paste these values. But of course this is not practical. Okay, you can do this, but it is not practical. So I'm going to show you how we can write these values of x directly to the Excel file. Okay, for this reason we are going to modify our dot file. Remember here, while we are reading the data from the Excel file, we first made a connection with the Excel sheet, then we started reading the data from the Excel sheet. And in order to write the data to an Excel sheet, you can write the data directly to the same sheet that you are reading the data. It's possible. So let me add another sheet, and let me rename it as results. Okay. Now I'm reading the data from this sheet, and I'm going to write the solution to this results page. In this case, you don't need to make another sheet connection. You can just start writing to the same Excel file. Remember, what I'm going to write, what I want to write is the value of my decision variables, x. So what I am going to do is I will say x. And remember, while reading the data, the keywords was from and sheet read. But when we are writing, the keywords are x2, okay, sheet write this time. Okay, not sheet read but sheet write. And the reference name for my Excel sheet, I defined it like this. So sheet write, and using the same format, in fact, I'm going to write the data to this. So again, I will select where to write, okay, and it will be on the results page. So results sheet, results, then exclamation mark, and where do you want to write on this results? So maybe I want to write it starting from A1, or you can start from B1, or you can start from B2, however you like. Okay, so I'm going to write it starting from A1. Okay, but the thing is, this X is not a single variable, as I told you. Since we are solving the problem with 5 products, then it means that I have 5 variables. So it means that my range should start from 1 and it should contain 5 cells. Okay, so I will write A1 to A5 because my I have 5 decision variables in this example, and that's it. X to sheet write this Excel sheet and give the address where you want to write it. And when you run the model, okay, it will give me an error message. Let me show it. So you may face the same error message. Basically, the reason for this error message, as you can see, it says the file is read-only because the Excel file is currently open, and when it is open externally, then CPLEX cannot write to it. So in order to avoid this mistake, you should close the file. Okay, and then let me run the model again. And now it is solved, and when it is solved, go and open this Excel file, and as you can see in this results page, now the values of the X variables are written starting from A1 up to A5. Okay, simply writing to an Excel file has this simple idea, but of course you may have different situations. So I want to show you these different situations, different errors, and etc. Okay, so sometimes it's not practical to read the data from the Excel file and write the solution to the same Excel file. Therefore, you read the data from an Excel file but write the data to a different Excel file. So in this case, what I'm going to do is I'm going to create another Excel file which will be my solution file. I will write the solution to this file. Basically, I will save, you can save this to anywhere in your hard drive, okay? But if you remember the previous lecture where we read the data, if this Excel file is outside of your project folder, then you should give the full address of this Excel file. If it is inside your project folder, then you can just give the name of the Excel file. Okay, now I'm going to save this to a separate place. Save as, let me save it here. Okay, so I will just save it here and I will give this name results. And let me show you where I saved it. It is over here, this results. And as you can see, it's currently empty, and the name of the sheet is sheet 1. There's only single sheet, so it's important to know this sheet name. If you like, you can change it. You can write it results, you can write it anything, or if you like, you can keep it as it is. Now, in order to write okay, to this Excel sheet, first thing again is to make a sheet connection, okay, like this one. So I will copy and paste this sheet connection. Now I have to give a different name. Okay, this was the reference name that I give to read the data. Now I give a different name. I will name it as results. Okay, maybe if you like you can write Excel result, and then I will write the full address of this file, which is this one. Simply I will copy it and paste it to here, and if you remember we need to have these double slashes over here, and I need to write the name of the Excel file, which is results.xlsx. okay, so this satisfies a connection with this sheet. Now I'm going to write this X to this sheet. Of course the name of the sheet is Excel result, and then I will write this in Excel results, and the name of the sheet is sheet 1. okay, so here I'm going to write sheet 1 and A1 to A5. Of course, in order to not to get this file writing error, I need to close this file. Okay, and I will run this configuration again. So now, as you can see, there are no error messages and it's solved. And let's see, as you can see, the results file also appeared here. Just double click on it, and as you can see, the result is written in sheet 1, and we have opened the file inside CPLEX. If you like, you can go to this address and open this results file from here as well, and you will see that the results are written here. Okay, so the next thing that I want to show you is, okay, in this example we have only 5 products, but what if you have 10 products? Then you need to come here and change it to A10. Then if you have 50 products, then you need to come here and write A1 up to A50. At each time you need to change this, but there is an easier way. In fact, you can give a range larger than your size of the variable. So for example, in this example I have 5 decision variables. If I write, for example, instead of A1 to A5, if I write A1 to A100, I don't have 100 variables, but still I'm writing it A1 up to A100. So I have just cleaned up the data and run the model. The size that I have given here, the range, is different than the decision variable, number of decision variables, but as you can see, CPLEX does not give me an error message. And when you open this Excel file, you see the correct values are written here. Okay, so again, let me show it from here as well. As you can see, the values are written. So you can give a larger range than necessary, and it will not be a problem. But the opposite is not correct. So I have 5 variables, for example, but I provide the range as from A1 to A2, a smaller range than my number of decision variables. Now when I run the model, of course, since the file is open, it will give me a read-only error message. So yes, I closed it and it gave me this error. It says Excel range has a bad size, it must be only 1 line or 1 row. And it means that basically the range, the size of the range that I provided is not satisfactory. So for being sure, For example, you can give a range which is larger than all possible values of decision variable for number of decision variables that you may use for this example. Okay, for example, A1 up to A200, and that's it. Now assume that another issue may be this. Assume that you want to write two different variables, okay, x and y. Let's assume that in your model you have both x variables and y variables. Then how you can write it? So you can write basically like this. Y, it is also, assume that it is also defined in your model, y to sheet write. Okay, so I'm going to write it to the same Excel file, Excel results, but I'm going to write it, for example, to B1 to B200. So in fact I'm writing this solutions x variables to here and y variables to here. If you want to write y to a separate sheet, then you need to add the second sheet, okay, and save the file, and then you can come here and you can say y to sheet write sheet, this time sheet 2 A1 to A100. So now what happens when you solve the model? It will write the solution, the values of x variables to sheet 1 on this A row, A column, and the values of y to this sheet 2 on this A column. Okay, and let me show you another thing. So in my model I don't have y, therefore I cannot write it. Now as you can see, when I run this model, it writes only the value of the decision variables. But maybe you want to see the objective function value in the Excel file as well. As you can see, the objective function value is written here, or it is written here, but I want to see it in my Excel file. So how can I do it? So we will use a simple trick over here. As you can see, my objective function is this. So instead of writing my objective function in this way, I will simply define an additional decision variable, the var float. So if you are sure that this objective function value will be positive, then you can add this plus. If you don't know if it is negative or positive, you can just ignore it, and I will say z. It's only a single value, and this z will represent the value of the objective function. So what can I do? Instead of writing this objective function in this way, simply I can say maximize z. But what is z? Z is, I am going to write it as a constraint, z will be equal to my objective function. Okay, so basically I'm doing the same thing. Instead of saying z is equal to this one and maximizing z, I can just delete z and write this directly to the objective function here, and it's the same thing. But why did I write it in this way? Because if I do it in this way, here I can say z to sheet write. Okay, I will copy this part over here. Z to sheet write, Excel sheet. I'm going to write it into sheet 2 and A1. Okay, only single value. Now if I run the model, after we find the solution, let me open this results file. Sorry, this is still not refreshed. Let me open it here, results file, and as you can see here in this sheet 1 I have these, and in this sheet 2 I have this one. By the way, I think this results file over here is not the results file in this folder. It is the results file in the project folder. So most probably there is a copy of that results file in the project folder. Let me show it. So if I just go to this project folder, and here, as you can see, there's a results file. I'm going to delete it because I'm not using it. So it may lead to confusion. You can say that, okay, I'm writing the result to this file, but it does not appear, or it is wrong. But in fact, you are writing the result file at a different folder, not to the file in your project folder. Okay, so now this one will refresh and disappear. As you can see shortly, now there is no results file over here. And you can see the results file in this folder. And as you can see, in sheet 1 there are the X values, and in sheet 2 there is this Z value. And if you like, you can do like this. You can write Z here. Okay, and let's delete this part. And also I can delete this one and write X here and save the file. And here, instead of starting this from A1, I'm going to start it from A2, and again from this A2. Now if I run the model after finding the solution, when I open the Excel file, you will see this X appears here and the values are written down, and this Z is written here and the values are written here. So why did I show this to you? Because if you like, you can organize, you can prepare your Excel file, you can format your Excel file, you can make these coloring, bold, center, borders, and etc. every format, and then you can write the values to a specific range, and you will have a very good formatted results file. Okay. Another thing that I want to show you is to write a decision variable with 2 indices. So again, let's remember our previous tutorials. We implemented this assignment problem. So as you can see in this problem, we have a decision variable X with 2 indices, xi, j. So it is not a single value, it is not a vector of values like in the previous one, but instead it is a table of values. Okay, so xij, I represents the rows and j represents the columns of this table. Okay, xij. So if this is x2 and 3, x2, 3 represents the second row, the third column of this table. So how can we write such a decision variable into Excel? Let me show it. So this was our implementation. Let me close this one. And we have this second configuration in which we are reading the data from this data file, and as you can see, this is our model minimize Cij, Xij subject to these 2 constraints. Now I want to write this solution of this and the values of this decision variables into Excel file. And in this example, let me open the project folder. Again, if you right click on the project, go to properties, and when you click on this one, it will open the project folder, which is this one. And as you can see, I'm reading, let me see, I'm reading the data from assignment data and assignment data cost. I am using 2 Excel values, 2 Excel files. Let me close this file and let me close this one as well. So as you can see in this assignment data, Okay, what I am reading from that assignment data file, I'm reading this is sheet. I'm reading number of jobs and number of machines from this, and I'm reading the cost from this sheet 2, which is assignment data cost. Although the cost appears in this file, still I am not using it, but I am reading the cost data from this second Excel file, which is this one. Okay, so you may clean up these and etc. Okay, now let's write the data to an Excel file for this example. Again, what I'm going to do is I will just create a new Excel file, and I will save this file. I will save it into the project folder. Let me see, yes, and this will be assignment results. Okay, and let me rename this sheet. So this will be the what, X variables. I don't know, you can give any name, but it's better to have meaningful names. I will write results. Okay, and I will close it after saving, of course. I will close this data file as well. And now again, what I am going to do, as you can see, if you like, you can make all sheet connections at the top, or you can write it anywhere, but of course this sheet connection should be done before you are using that sheet. So for example, here, if you write this sheet connection down to here, you are trying to read the data from this sheet, but you are making the sheet connection down. In this case, you may get an error message. Therefore, instead, it's better to make all these sheet connections at the top of the data file. So I will write sheet connection, and this time I will say sheet results. So this will be the reference name for me. And since the file is under the project folder, I will not give the path, but just write the name, which is assignment results. Assignment results dot xlsx. Okay, this file name is very important, should be consistent. Okay, don't forget these semicolons at the end, otherwise again you will receive error messages. And now, after reading these data, I'm going to write the solution. So how do we do? X, remember this is xij, but we are not using indices here. We just say x to sheet right, and it will be sheet results, this one over here. Okay, and then I want to write it to where. I changed the name of the sheet. It was results, if you remember. Let me reopen it. And as you can see, the name of the sheet is results. So results, and now I need to give the range. Okay, where do I want to write it? And for this, I need to know what's the size of this X. Okay, it is jobs and machines. And jobs goes from 1 to n jobs, machines goes from 1 to n machines, and I'm reading these jobs and machines, number of jobs and machines here. As you can see, number of jobs is 4 and number of machines is also 4. So it will be a matrix 4 by 4. So you can start from this A1, go to this 4 and go to this 4. As you can see, this is 4 by 4 selection, so it will be from A1 to D4. Okay, so I'm going to write this results starting from A1 to D4. Okay, and let me run it, of course, after closing the file. Let me run this configuration. Now as you can see the solution, you can see the solution here, or you can just click on this. The solution is here, and as you can see here, there is more information. When we write into Excel, we don't see it in this format because the value of the decision variable is written here, 0. The others are related with the sensitivity analysis. Okay, so if you don't know sensitivity analysis, of course you will not be able to understand, but the basic idea is it says that these numbers over here shows the lower and upper bounds for the variables values, so up to which values of these decision variables the current solution stays the optimal, and etc. Those kind of information is written here. Okay, so let's see the results. Where is the results written? Here. As you can see on this sheet 1, the results are written in this format. Okay, now as I told you, instead of giving A1 to D4, you can say this is A1 to X, let's say 100, a larger range, and even it is not square. Okay, and when you run it, of course after closing the Excel file, we shouldn't receive any error message since the Excel size that I provided is much larger than the values of these decision variables. Okay, so let me show it. Still it will write the same thing. Sorry, so as you can see, it's written in a different way because I provided the range from A1 to, let's say, X100, and since there is 4 by 4 data, there is only 16 data, it starts writing from the top left row and writes the value through right until it reaches to the end of the range that we give it to Excel. So as you can see, all the data are written on a single row. But what does it mean? These four elements are the first row, these are the second row, so you can just copy them to here, and these are the third row, you can just copy here, and this is the fourth row, and in fact this is the result. So what does it mean? Job 1 machine 4, job 2 machine 2, job 3 machine 3, and job 4 machine 1. The assignments are in this way. So maybe here, instead of giving such a large range, it's more readable to give this A1 to D4 exactly the same size, so that you obtain exactly the same solution. And also in our previous tutorials, I showed you that instead of writing the ranges, you can give names to these ranges and then use these names to write the solutions, and you can do the same thing while reading and writing. So let me show. Instead of writing these A1 to D4 into Excel, now I will name this range as, for example, X values. Okay, now this range from A1 to D4 is named as X values, and here instead of writing results A1 to D4, I will just write X values. Okay, and then when I run it, of course after closing it, so let's see the Excel file. We haven't received any error messages, which is good, and as you can see, the data is written to this range X values. Okay, so basically this is how we can write the solution to an Excel file. And again, here if you want to write the objective function also, you can do the same thing. You can define another decision variable, float z, and then you can just say minimize z, subject to, just write a constraint saying that z is equal to this constraint, and in this data file we can say, we can just copy these values, z to sheet results. I'm going to write z value over here. Okay, but currently I don't have this z value. What I'm going to do is I'm going to add another sheet, rename it as objective, and I'm going to name this as z value. And after saving the file, I will close it and I will run the model. When we got the solution, open the results file, and as you can see, in this results sheet we have the X values, and in this objective sheet we have the Z value. Okay, so in fact reading the data is easy, convenient, practical for CPLEX OPL, and but sometimes it may be slower. So if you are making sheet connections to a lot of different Excel sheets, first reading all those data will take some time for CPLEX. After that time, it will start to solve the problem. So when you write the data directly into the dot file, sometimes it's faster than reading it from the Excel file, but still it's very convenient to do so. Okay, so I hope you learned how to write the solution, the optimal variable values to this Excel file.